Welcome back to our lesson. We are continuing to discuss the chemical properties of chlorine. Remember, in our first session, we discussed about the acidic nature of chlorine. We saw that it is acidic gas and it turns moist blue litmus paper red and then bleaches the paper. We went ahead and saw that chlorine dissolves in water to form chlorine water. And what do you think is the contents of chlorine water? Name the compounds that are present in chlorine water. So chlorine water, we said, contains chloric 1 acid and hydrochloric acid. So which of these two components makes this particular chlorine water to be yellow in color or green yellow in color? We said that it is the chloric 1 acid. So what happens when this particular chlorine water is exposed into air as seen here? Okay, as seen here. What happens when it is exposed to air? There were two observations. There was formation of oxygen, hence there is collection of alkalis gas here, and the chlorine water decolorizes. That is what we observed during our previous session. Now, in our next session, we shall learn about something different. Yeah, shall learn about the the reaction between chlorine and metals. Shall learn about reaction of chlorine with metals. So chlorine reacts with metals, and when it does so, it forms some metallic chlorides. Okay, it forms some metallic chlorides. So we shall first of all investigate how chlorine burn or how sodium burn in chlorine. So when a piece of burning sodium is lowered into a gas jar containing chlorine gas, it continues burning, hence forming sodium chloride. Sodium chloride is white in color. Therefore, there is production of white fumes of sodium chloride, and this is the equation for the reaction. So sodium will react with chlorine gas, and this forms sodium chloride. Okay. In a similar way, magnesium continue burning in chlorine gas, and it forms white fumes, which is magnesium chloride. So we say here that magnesium reacts with chlorine to form magnesium chloride in the equation. Okay. Now, the magnesium continue burning because the heat that is generated during the reaction sustains the reaction. The heat is sufficient to ensure that the reaction continues. That's why magnesium keeps on burning when it is lowered into a gas jar containing chlorine. Okay? Now, what happens when chlorine is made to react with iron wire? So when chlorine is passed over glowing iron wire, the wire continues to glow, even if the heat is removed. This is because the reaction between chlorine and iron is highly exothermic. It produces a lot of heat. Okay, that's why it continues to glow. Okay, now it forms red-brown fumes, and these red-brown fumes are actually iron 3 chloride. The iron 3 chloride. So we are saying that when iron reacts, or when burning iron is made to react with chlorine, it continues to glow, hence producing red-brown fumes of iron 3 chloride. This iron 3 chloride sublimes on heating. Okay, so we shall investigate this using the next diagram. So we want to say this, that okay, thank you. Yeah, that when you have dry chlorine here passing through the combustion tube where you have iron filings, these iron filings continue to glow, or they glow as chlorine passes through in here. Okay, this is because the iron react with chlorine and it forms iron 3 chloride, this one. Okay, so iron 3 chloride formed in this combustion tube here will sublime on heating. We learned in Form 1 that iron 3 chloride is one of the substances that sublime on heating. So, okay, so we are saying here, okay, I'm sorry, there is a mix-up of slides. Okay, let us move on. So we are saying here that the dry chlorine will react with iron, and as it reacts with iron, these iron filings will glow. It will continue glowing, and then it produces red-brown fumes. The red-brown fumes will be observed in the combustion tube, but they will condense on the cooler parts of this particular conical flask as iron 3 chloride. This is because it does not form inside this combustion tube, because when it is heated, the iron 3 chloride formed sublimes and it condenses and cools on the cooler parts of the conical flask connected towards this end here. Okay, good. So the iron 3 chloride formed is deliquescent, highly deliquescent, meaning that when exposed into air, it actually combines with atmospheric water to form a solution. So to prevent that, we normally have this guard tube here. The guard tube contains calcium oxide. So calcium oxide will absorb any moisture from the surrounding or from the flask, hence making the air inside here to be dry. Okay, if it is dry, the iron 3 chloride formed will not absorb the moisture from the air, hence it will remain as red-brown crystals. Okay, the other function of calcium oxide here is also to react with the excess chlorine, because we learned that chlorine is poisonous, hence it has to be removed. So that is the purpose of this guard tube, which contains calcium oxide. So I've said the calcium oxide has got two main functions. The first one here is to remove any water vapor or moisture which is found in the flask, and also preventing moisture from the atmosphere from coming into the flask. And number two, it is to react with any unreacted chlorine, hence preventing it from being exposed into the atmosphere, because chlorine is highly poisonous and it causes acid rain. Okay, that is the meaning or the function of that guard tube here. Good. So what have we learned about reaction between chlorine and metals? We have learned that chlorine reacts with metals to form metallic chlorides. Okay? Now, NB. When metal has got more than one oxidation number, okay, the chloride of the metal formed will be that of higher oxidation number. What am I trying to say here? For example, iron is capable of forming oxides or chlorides with oxidation number of 2 and iron with oxidation number of 3. Okay? So, the chloride with oxidation number 3 is formed here, but this one, oxidation number 2, is not formed. This is because chlorine is a strong oxidizing agent. Chlorine is a strong oxidizing agent, hence it will lead to formation of iron 3 chloride, but not iron 2 chloride. That is, the chloride with the higher oxidation number is formed. The chloride with the higher oxidation number is formed. The reason is that chlorine is a strong oxidizing agent, hence there is formation of iron 3 chloride but not iron 2 chloride. Have you understood? Good. So this actually is how chlorine reacts with metals. Okay? Now, let us move on and discuss about reaction of chlorine with nonmetals. Reaction of chlorine with nonmetals. So, chlorine reacts with nonmetals forming a nonmetallic chloride or forming nonmetallic chlorides. For example, when red phosphorus is lowered into a gas jar containing chlorine, okay, the reaction occurs, hence producing white fumes. And these fumes is a mixture of phosphorus 3 and phosphorus 5 chloride. Okay? So when you have a gas jar which contains chlorine, and you lower deflagrating spoon containing phosphorus, okay, it will actually continue to burn. It will continue to burn, hence producing white fumes. And these white fumes is a mixture of two nonmetallic chlorides, and that is phosphorus 3 and phosphorus 5 chloride. These are the equations for the reactions occurring. That is, phosphorus react with chlorine to form phosphorus 3 chloride, and also phosphorus react with chlorine to form phosphorus 5 chloride. Okay. What about reaction with hydrogen? Chlorine react with hydrogen when burnt in a jet, and the hydrogen will continue burning, producing white fumes. So it will produce white fumes of hydrogen chloride, which will be seen on the mount of the gas jar. It will be seen on the mount of the gas jar. So we are saying that hydrogen will react with chlorine, and this forms hydrogen chloride gas. This gas will form white fumes. Is it clear? Okay. Yeah. Hence, forming the hydrogen chloride. So generally, we can say that chlorine is capable of reacting with some nonmetals, and if it reacts, then it forms nonmetallic chlorides. Sawa sawa. Okay. Now, we want to move on and discuss about how chlorine reacts with alkalis. Chlorine is acidic gas. Therefore, it reacts with alkalis, hence neutralizing the alkalis. The product formed when chlorine reacts with alkalis depends on temperature and concentration of the alkali. These are the two properties or two factors that will lead to formation of the product. For instance, it reacts with cold sodium hydroxide. called sodium hydroxide or potassium hydroxide. If these alkalis are cold or if it is low temperature, the products formed will be sodium chloride and sodium chlorite 1. Note that. Sodium chloride and sodium chlorite 1 and water. So these are the products formed when you use cold alkali. For instance, chlorine will react with sodium and this forms sodium chloride and sodium chlorite 1 and water. Similarly, when chlorine gas react with potassium hydroxide, it forms potassium chloride, potassium chlorite 1 and water. Okay? Good. So we can say here that the chlorine gas react with the hydroxide ions, that is the ionic equation, and this forms the chloride ions, chlorite 1 ions and water. What if now you use higher concentration of the alkali and at a higher temperature? So when hot concentrated alkali is used, okay, there is formation of the chloride and chlorate 5. Okay, this is supposed to be chlorate 5. So for instance, if you have chlorine gas and you bubble it through concentrated sodium hydroxide at a temperature of about 70 degrees Celsius, there will be formation of sodium chloride and sodium chlorate 5. You can note the difference. When the temperature is low, there is formation of sodium chloride and sodium chlorite 1 and water. On the other hand, when you use concentrated alkali at a high temperature, for instance, chlorine reacts with sodium chloride here, and this forms sodium chloride. I'm saying chlorine reacts with sodium hydroxide, and this forms salt called sodium chloride and sodium chlorate 5. This is the name, sodium chlorate 5. Okay, so it actually forms sodium chlorate 5. So difference between chlorite 1 and chlorate 5 is that chlorate 1 it has got only one O. Chlorite 1 has got only one O, while chlorate 5 it has got 3 O's. Okay, so at a higher temperature and when you use a higher concentration, you will form sodium chlorate 5 and sodium chloride. Sawa sawa. So that is how chlorine reacts with alkalis. So we can say that chlorine being acidic, it neutralizes alkalis to form salts and water. But the type of salts formed depends on 1, concentration of the alkali, and 2, the temperature at which the reaction is conducted. Like when the temperature is low, there is formation of sodium chloride when you use sodium hydroxide and sodium chlorite 1. But when temperature is high and you use a higher concentration, there will be formation of sodium chloride and sodium chlorate 5. Okay? Thank you very much. Thank you very much. Now, last but not least, let us investigate reaction of chlorine with bromide and iodides. Okay, reaction between chlorine with bromide and iodide ion. That is, we want to talk about displacement reactions. At this particular time, let us see whether we can have a video. So we shall actually dwell our discussion here on this particular video. Okay. Unfortunately, it has escaped. Okay. Okay.
Here we are with a series of halogen halide ion displacement reactions in the Here we are with a series of halogen halide ion displacement reactions. In the first 3 conical flasks here, we have potassium chloride. In the second 3 conical flask, we have potassium bromide. And in the third set of 3 conical flasks, we have potassium.
Yeah, let us.
Here we are with a series.
Okay, let us actually look at this particular video so that we understand how chlorine displaces other halides from their solutions. Okay, good.
Series of halogen halide ion displacement reactions. Here we are with a series of halogen halide ion displacement reactions. In the first 3 conical flasks here, we have potassium chloride. In the second 3 conical flask, we have potassium bromide. And in the third set of 3 conical flasks, we have potassium iodide. Into each of them, we're going to sequentially put iodine in this row, bromine water into this row, and chlorine water into this row. So let's have a look if any displacement reactions occur. Here's the iodine. You can see it stain the bottle deep brown colour. We're familiar with iodine. And if we place an approximate equal amount, a few mils, into each of those solutions, we see not much difference in the 3. Same colour for the iodine, and nothing appears to have happened. Into the second sequence of flasks, we're going to put bromine water. So this is quite nasty stuff. And there's the bromine water. Quickly put the top back on the bottle. The bromine water, 0.02 molar. And let's introduce that into the 3 flasks. So we've got into the first flask, which is in bromine water in potassium chloride. This is bromine water into potassium bromide. And finally, bromine water into potassium iodide. And hopefully you can see there that the bromine into potassium iodide has turned a much deeper orange colour than the other 2, perhaps indicating a difference in the reaction. Finally, we have chlorine water. Here's the chlorine water, and we're going to introduce that into the 3 flasks. So first, let's put some chlorine water into the potassium chloride. Then chlorine water into potassium bromide. And finally, chlorine water into potassium iodide. So once again, you can see a difference in the intensity of the colours there. The chlorine into potassium chloride, no noticeable change, but both into the chlorine into the potassium bromide, we've got a development of an orange-yellow colour, and into the potassium iodide, we've got that familiar iodine colour present there. So
Okay, thank you. Thank you very much. Okay, so what have you learned from the just concluded video? Okay, so you have learned that in this first row, there was addition of chlorine. Okay, and the second row, there was addition of bromine. And in the third row, there was addition of iodine. Okay, so my target here, or my aim here, is actually to investigate this first row, or row, let me use row 1, the one which chlorine was added, because that is our point of interest. So in this first conical flask, there was addition of potassium chloride, and then in the second conical flask, there was addition of potassium bromide, And then the last one here, there was addition of potassium iodide. Okay, so we have seen in this conical flask where potassium chloride was added, when you add chlorine in here, there was no significant change because chlorine do not displace another chlorine from a solution. Okay, and when you added chlorine water, we saw that when you added chlorine water in this particular conical flask 2, this one here, okay, flask 2, this one, okay, yeah, the second flask, there was actually the bromine was displaced by chlorine. Able to see? The solution was initially colorless because potassium bromide is colorless. Is it clear? But when you added chlorine, the bromine was decolorized, hence there was formation of a yellowish solution. And in the third boiling conical flask here, when you added chlorine in potassium iodide, there was formation of a red-brown solution, which is due to displacement of bromine. So this means that chlorine is capable of displacing other halogens like bromine and iodine from their solutions. Is it clear? Let us have a look at the literature so that we understand better. Good. So we are saying here that chlorine reacts with other halides. Good. With other halides. Good. It reacts with other halides, that is bromides and iodide, and it displaces them. So chlorine has got a higher affinity of electrons than bromine and iodine. Hence, it takes electrons from the bromide ions and iodide ions, hence forming neutral atoms of bromine and iodine, respectively. Therefore, displacing them from their solutions. So in that first case, we saw that chlorine, when is added in potassium bromide, which is a colorless solution, it forms potassium chloride and bromine. The bromine is red-brown in color. Okay? On the other hand, when chlorine is bubbled through potassium iodide, we saw that there is formation of potassium chloride and the red-brown iodine. Okay, the red-brown iodine. This is an example of displacement reaction. So chlorine is more reactive than both iodine and bromine. So when these two halogens are in their solutions, like in potassium iodide and in potassium bromide, chlorine will displace them. Sawa, because it has got a higher affinity for electrons, hence it will displace them. Therefore, there will be formation of potassium chloride when you react with bromine, and the bromine is displaced. Therefore, the solution becomes a bit red-brown. On the other hand, also, when chlorine is bubbled through potassium iodide, okay, there is formation of potassium chloride and the iodine is displaced. Sawa. Therefore, we can say that chlorine displaces both bromine and iodine in their solution. Chlorine displaces both bromine and iodine from their solutions to form, you can see here that the chloride remains in solution form while our iodine is displaced. Similarly here, there is formation of the chloride and the bromine is displaced. Okay, so we shall stop there for now. We shall have our next session later. So bye bye. Have a nice time.